All right, now that we've gone through the definitions, remember that craton, that's that center, the heart of the continent, the rocky center of the continent, and the orogenic belts, the mountains that often are along the outsides of the continents. Now we get to talk about what was actually happening to these cratons. Now, the Paleozoic history in North America is marked by repeated sea level rises, which we call transgressions, and sea level falls, which we call regressions. And when sea level rose, the continent was covered by epicontinental seas. When sea level fell, it went back to being exposed land surface. Now, in this table / image on the slide, notice that zigzag pattern between yellow, which means there was mostly land, and green, meaning there was an epicontinental sea that moved in, right? So transgression, epicontinental sea moves in, regression, it heads back out. Okay? So regressions exposed old sea floor that were once covered by water to erosion. So that often created a lot of unconformities, right? Gaps in the rock cycle. And we can use these unconformities to separate each transgression regression sequence. Not only can we use these unconformities to place the boundaries between each of these transgression regression sequences, we can also use the rocks that are deposited during these sequences. In this image, notice that as sea level transgresses, we get this pattern of sea or coastal and ocean facies, where we start with the fluvial, meaning riverine, and then the beach, and then the shore, and then the open shelf, the open ocean. Those facies move on up, heading over to your left as sea level rises. And then as sea level falls, those three facies, or those four facies, again, move on up, but over to your left, or sorry, over to your right as the sea level falls, right? And as this pattern goes on, they'll zigzag to your left as sea level rises, zigzag to your right as sea level falls, right? Transgression, regression, creating this zigzag pattern in the sediment record and in the rock record, right? Now, what other kinds of sedimentary rocks and minerals do you think would be produced during a sea level regression when sea level was falling? In other words, what else might we use to define the sequence in the rock record? Okay, now, when I think of sea level falling, I think of ocean water drying up, right? Ocean water being left behind in shallow lagoons drying up. And when I think of drying up salt water, I think of salt, gypsum, other deposits that are precipitated out when water evaporates. And we call these deposits evaporites, right? So during the regressive sequence, when sea level was falling, evaporites such as halite and gypsum were deposited. And actually near the close of the Tippecanoe sequence, the evaporation in the Michigan Basin caused the halite and gypsum to be deposited on an immense scale. Now these deposits are up to 750 meters thick. So there's a really good chance that if you have eaten a potato chip in your life, you have eaten salt from this deposit, because we get a lot of our salt from this deposit.